This is lesson 4-3, graphs and the graphical features of functions. Some new vocabulary that we need to discuss for this particular section. A discrete function has a graph of distinct, isolated points only. In other words, these points on a graph are not connected. A continuous function, however, has an unbroken graph of points. In other words, we take all of the points and we connect them. To decide if a function should be discrete or continuous, ask yourself the question, given the situation that you've just read about, do all values, both in the domain and the range, make sense for this function? Here's an example of what I'm talking about. If you're graphing the weights of different cheeses made on any given day, that would be continuous since all weights are possible. In fact, decimal weights are quite frequent when we're talking about the weighing of food. However, graphing the number of new cars sold in a given month would be discrete. You can't sell half of a new car to somebody. And if you're in that situation where you're buying half of a new car, someone is ripping you off. Let's talk about the features of a function graph. First, the movement characteristics of any function. These are pretty simple. The function is increasing when any range values are going up. The function will be decreasing when the range values are going down. And the function is constant when there is no change in the range values. Very simply read on a graph. When giving intervals about movement using interval notation, it's very important to only use parentheses. We are not going to be using staple brackets when talking about intervals of movement. Intercepts are where the graphs of any function cross the axes. For example, an x-intercept is where the graph crosses the x-axis. An x-intercept is also called the zero of a function. We'll be using that term a lot more as we move into specific functions called quadratics. The y-intercept is where the graph crosses the y-axis. We'll be using that a lot more when we do linear functions. You're probably familiar with that term with graphing lines. Keep in mind that any function cannot have more than one y-intercept because then the graph would fail the vertical line test. Here's your procedure for graphing any function. The first thing you want to do is set up a 4-column table. You want to set it up with your independent variable, and you are allowed to choose your own values. You should select a minimum of 5 and include the numbers that make sense to the situation. The next column should be the rule column where you are doing your calculations. Next should be the dependent variable column. And finally, the last column should be what your ordered pair is so that you can easily graph it from the table. Next, complete the table. You should use a calculator to find your dependent values. Next, plot your points on a graph, and then connect your points only if you determine that the function is continuous. Check your graph on the graphing calculator if necessary. We'll be doing that in the coming lesson. Make sure that you answer any follow-up questions about the features that may be asked in the question. Here's a graphing example. I want you to graph the function rule. I've set up the table for you, and notice that I picked -2, -1, 0, 1, and 2 for the x values. First of all, let me be very clear. Those were my picks. The reason I picked them is that those 5 values make up the middle of the graph. And I want to see how the graph behaves in the middle. Pause the video at this point to fill the table in for yourself, as well as graphing the function. So we have our values selected, and now I'm going to plug them in. So y is going to be equal to 2 minus negative 2, which is going to be positive 4. So my point is 2, 4. I fill in my rows all the way around. And notice that I'm making mistakes here that I need to first take care of. Pardon me for that. Notice that I'm putting my negative values in parentheses so I don't get confused with the original minus sign. Once they become positive, I don't necessarily have to use parentheses anymore. Now that I have my 5 points, I want to plot these on my graph. Now, notice I have my axes already drawn for me. I want to label my axes as X and Y, and I want to put some units in each direction. In your notes, you should be sketching this graph. Now, in no way, shape, or form do I have to go up by ones, but in this case, it's very easy for me to go up by ones, and I'll encompass everything that I need. I want to plot the point negative 2, 4. Now, some people like to put the coordinates next to it. Not something I do. If you want to, go right ahead. Negative 1, 3, 0, 2, 1, 1, 2, 0. Now, since there is no specific situation with this function, it's just the function itself, I can assume it's continuous at this point. So I do want to graph my function, and I can't use a ruler on the smartboard, but you should be using a ruler or a straight edge in your notes. Arrowheads on the end of the line, and label your function. And I don't have any follow-up questions, so I have completed this example. Let's take a look at another example. That's a graphing example. The cost, C, in dollars for bananas depends on the weight, W, in pounds of the bananas. This situation is represented by the function rule C equals 0.5W. First of all, it is a continuous function because of the fact that all weights are possible, as are all costs. We can have decimal values for costs. What's interesting about this function is that if we're talking about dollars and weight, they have to be positive values. So notice that I've decided to use just the upper right quadrant of my graph. We call this a quadrant graph. And the reason I'm going to do that is because I'm only using positive numbers. As you can see, what I'm putting in my chart. Now pause the video at this point to give yourself a chance to complete the example on your own. At this point, I want to be putting in my weights. And I will continue to do that throughout. And finishing up with 4. now I'll plot my points. And again, we have the W axis down here, the C axis up here. I'm going to again go up by ones. Start at 0, 0. Now, if you wanted to go up by halves, you could. I don't feel the need to do that. 0.5 is directly in the middle of 0 and 1, so I'm going to plot my point right here. Then I got 2, 1, 3, 1.5, and 4, 2. At this point, I said it was continuous, so I can draw my line. Now, what's interesting about this function, because I'm only using positive values, I only want an arrowhead on that side. I want to label my function, c equals 0.5w, and there are no follow-up questions, so I'm good with this example. This is a reading of the graph example. The function y equals f of x is graphed over the interval -7 is less than or equal to x, which is less than or equal to 7. That's inequality notation. What that's stating is the x values that I'm graphing this over start at -7 and go up to +7, as you can clearly see. I want you to find and state the y-intercept, find and state the x-intercept or intercepts if you see more than one. Name one interval where the function is increasing, and then name one interval that the function is decreasing. Pause the video at this point to give yourself a chance to try it on your own. So, the y-intercept is where the graph crosses the y-axis. That is right at this point right here. Remember, the y-intercept is a point, so I do need to give it coordinates. And the coordinates of the y-intercept in this case are going to be the point 0, 6. Now, x-intercepts, I have two of them. Right here and right here, the graph crosses the x-axis. This here is -6, 0. And this is -4, 0. So those are my two x-intercepts. Name one interval where the function is increasing. So, erase these two x-intercepts here. The function is increasing when it's going up. From this point right here to this point right here, the function is going up. So, the interval needs to be written in interval notation. And in this case, this is x equal to -5. This is x equal to -1. Remember that anytime we're talking about increasing or decreasing movement, we use parentheses. So your possible answer here could be -5, comma, -1. Also, this point right here where x is equal to 2, and this point right here where x is equal to 5 is also an increasing part of the function. So you could also have 2, 5 with parentheses around both. For decreasing, we can start with this right here, where -7 is the x value, and it goes to -5. We also can do this one here, -1, down to +2. So you could have -1, 2. And finally, this one right here to this one right here, you could have 5 to 7. Any one of those three works just fine. If you're having any issues in any portion of this lesson, please make sure you are emailing me or consulting me in class.